OSHA defines low voltage as electrical current less than 50 volts. OSHA requires employers to establish a lockout tagout program for any electrical systems, regardless of voltage, if certain conditions exist. These conditions are: firstly, the system is exposed to a potential electrical hazard. Secondly, employees are exposed to energized electrical equipment. Thirdly, the equipment or circuit being worked on could be inadvertently energized. Specifically for 28-volt systems, OSHA considers 28 volts to be a low-voltage hazard. It requires employers to implement lockout tagout procedures if the system operates in a wet or conductive environment. Also, if employees are exposed to the system's magnetic field. And lastly, if the system is capable of causing burns or other injuries due to arcing or shock. In addition to OSHA requirements, the National Fire Protection Association 70E also provides guidance for electrical safety. NFPA 70E classifies 28 volts as a limited energy source and recommends that lockout tagout procedures be followed for any work involving circuits with potential hazards due to stored energy, such as capacitors or batteries, circuits that could produce arcs or explosions due to faults or overloads, and circuits that are not isolated from higher voltage sources. Understanding these regulations is crucial for maintaining a safe working environment when dealing with low-voltage electrical systems. Lockout tagout, often abbreviated as LOTO, is a critical safety procedure designed to protect workers from hazardous energy releases during the servicing or maintenance of equipment. It involves isolating energy sources and preventing the unexpected startup or release of stored energy that could cause injury. The core principle of lockout tagout is to ensure that equipment is de-energized and rendered safe before any work begins. This is achieved by physically disconnecting and isolating all energy sources, such as electrical, mechanical, hydraulic, pneumatic, chemical, and thermal energy. Once the energy sources are isolated, a lockout device, typically a lock, is attached to the energy isolating device, preventing it from being re-energized. A tag indicating that the equipment is out of service is also attached to the lockout device. This tag provides information about why the equipment is locked out and who authorized the lockout. There are several key steps involved in implementing a lockout tagout procedure. Firstly, preparation for shutdown is crucial. This involves identifying all energy sources and understanding the potential hazards associated with each energy source. Secondly, shutting down the equipment in a safe and orderly manner is essential. This may involve following specific procedures to avoid damaging the equipment or creating additional hazards. Thirdly, isolating the equipment from all energy sources is paramount. This typically involves disconnecting electrical circuits, closing valves, and blocking mechanical parts. Fourthly, applying lockout tagout devices to the energy isolating devices ensures that the equipment cannot be inadvertently re-energized. Fifthly, releasing any stored energy, such as compressed air or hydraulic pressure, is necessary to eliminate potential hazards. Sixthly, verifying the isolation of the equipment by testing or visually inspecting the energy isolating devices confirms that the equipment is safe to work on. Lockout devices are typically locks that are attached to energy isolating devices. These locks are designed to prevent the energy isolating devices from being operated. Each authorized employee should have their own lock, which they are responsible for securing and removing. Tagout devices are typically tags that are attached to energy isolating devices. These tags provide information about why the equipment is locked out and who authorized the lockout. Tags are used when lockout devices cannot be applied or when additional warning is needed. The selection of appropriate lockout tagout devices is crucial for ensuring the effectiveness of the procedure. Devices should be durable, standardized, and easily identifiable. They should also be compatible with the energy isolating devices to which they are attached. Training is an essential component of any effective lockout tagout program. All employees who may be involved in servicing or maintaining equipment must be trained on the procedures and requirements of the program. Training should cover the identification of energy sources, the steps involved in lockout tagout, the use of lockout tagout devices, and the potential hazards associated with hazardous energy. Periodic audits are necessary to ensure that the Lockout Tagout program is being followed correctly and that the procedures are effective. Audits should involve observing employees performing Lockout Tagout procedures and reviewing the program documentation. Any deficiencies identified during the audit should be corrected promptly. OSHA's Lockout Tagout standard, found in Title 29 of the Code of Federal Regulations, Section 1910.147, outlines the requirements for controlling hazardous energy during servicing and maintenance of equipment. The standard applies to a wide range of industries and equipment, and it is essential for employers to comply with its provisions to protect their employees from injury. The standard requires employers to develop, implement, and enforce a written Lockout Tagout program. The program must include procedures for identifying energy sources, isolating equipment, applying Lockout Tagout devices, and verifying the isolation of equipment. The standard also requires employers to train employees on the requirements of the program and to conduct periodic audits to ensure its effectiveness. The benefits of implementing a Lockout Tagout program are numerous. Firstly, it protects employees from injury or death due to hazardous energy releases. Secondly, it reduces the risk of equipment damage and downtime. Thirdly, it improves employee morale and productivity. Fourthly, it demonstrates a commitment to safety and compliance with OSHA regulations. Implementing a Lockout Tagout program can be challenging, but it is essential for protecting workers from hazardous energy. By following the steps outlined in this discussion and complying with OSHA's Lockout Tagout standard, employers can create a safe and productive work environment. Specific steps for performing Lockout Tagout include: firstly, identify all sources of energy that could pose a hazard to employees. This includes electrical, mechanical, hydraulic, pneumatic, chemical, and thermal energy. Secondly, notify all affected employees that the equipment will be shut down and locked out. Thirdly, shut down the equipment using the normal operating procedures. Fourthly, isolate the equipment from all energy sources. This may involve disconnecting electrical circuits, closing valves, and blocking mechanical parts. Fifthly, apply Lockout Tagout devices to the energy isolating devices. Each authorized employee should have their own lock, which they are responsible for securing and removing. Sixthly, release any stored energy, such as compressed air or hydraulic pressure. Seventhly, verify the isolation of the equipment by testing or visually inspecting the energy isolating devices. Eighthly, perform the servicing or maintenance work. Ninthly, remove the Lockout Tagout devices after the work is completed and the equipment is safe to operate. Tenthly, notify all affected employees that the equipment is ready to be restarted. 11thly, restart the equipment using the normal operating procedures. Key elements of a Lockout Tagout program include: firstly, a written program that outlines the procedures for controlling hazardous energy. Secondly, training for all employees who may be involved in servicing or maintaining equipment. Thirdly, Lockout Tagout devices that are durable, standardized, and easily identifiable. Fourthly, periodic audits to ensure that the program is being followed correctly and that the procedures are effective. Common mistakes to avoid when performing Lockout Tagout include: firstly, failing to identify all energy sources. Secondly, failing to notify all affected employees. Thirdly, failing to shut down the equipment properly. Fourthly, failing to isolate the equipment from all energy sources. Fifthly, failing to apply Lockout Tagout devices correctly. Sixthly, failing to release stored energy. Seventhly, failing to verify the isolation of the equipment. Eighthly, removing Lockout Tagout devices prematurely. Ninthly, restarting the equipment without notifying all affected employees. Tenthly, failing to follow the written Lockout Tagout program. Additional considerations for low-voltage systems include: firstly, even though low-voltage systems may not seem as dangerous as high-voltage systems, they can still pose a hazard. Secondly, Lockout Tagout procedures should be followed for all electrical systems, regardless of voltage. Thirdly, special precautions may be necessary when working on low-voltage systems in wet or conductive environments. Fourthly, employees should be trained in the specific hazards associated with low-voltage systems. Fifthly, the National Fire Protection Association 70 provides guidance for electrical safety in the workplace, including specific recommendations for low-voltage systems. Understanding the definition of low voltage according to OSHA is key to proper application of safety procedures. The 50-volt threshold serves as an important demarcation for electrical safety protocols. The 28-volt systems mentioned specifically fall well within this low-voltage category, but as outlined before, require specific considerations for lockout tagout procedures. The requirements depend on the specific circumstances of the system's operation and environment. Factors such as wet conditions, magnetic field exposure, and the potential for arcing or shock all contribute to the need for rigorous lockout tagout practices. It is crucial to assess each situation carefully and implement appropriate safety measures. Consulting NFPA 70 can provide further guidance on managing electrical hazards associated with low-voltage systems, especially regarding stored energy, arcing, and isolation from higher voltage sources. The NFPA 70 standard offers comprehensive recommendations for electrical safety in the workplace, complementing OSHA's requirements and providing detailed guidance on how to implement safe work practices. Following both OSHA and NFPA 70 guidelines ensures a robust approach to electrical safety. Lockout tagout procedures are not merely a formality, but a critical component of a comprehensive safety program designed to protect workers from harm. By diligently following these procedures, employees can minimize the risk of electrical accidents and create a safer working environment. It's essential to emphasize the importance of ongoing training and regular audits to maintain the effectiveness of lockout tagout programs. This ensures that employees remain knowledgeable and compliant with safety protocols, and that any deficiencies in the program are promptly addressed. Understanding the specific hazards associated with low-voltage systems, such as the potential for arcing and shock in wet environments, is crucial for implementing appropriate safety measures. These hazards may not be immediately obvious, but they can still pose a significant risk to workers. It's important to remember that even low-voltage systems can be dangerous under certain circumstances. Lockout tagout procedures should be followed diligently to minimize the risk of electrical accidents. In summary, OSHA's low-voltage lockout tagout requirements are designed to protect workers from hazardous energy releases during servicing and maintenance of electrical equipment. These requirements apply to all electrical systems, regardless of voltage, but special considerations are necessary for low-voltage systems, such as the potential for arcing and shock in wet environments. Employers should implement a written lockout tagout program, train employees on the requirements of the program, and conduct periodic audits to ensure its effectiveness. Compliance with OSHA and NFPA 70 guidelines is essential for creating a safe and productive work environment.